Welcome back, everybody, to another deep dive. Today, we're going to be tackling something pretty mind-bending. We're talking quantum computing. Specifically, Microsoft's claim that they can bring practical quantum computing to us within years, not decades, like a lot of people have been predicting.
Yeah, it's a pretty big statement, a pretty audacious statement considering all the complexities that we're dealing with when it comes to this technology.
Right.
Quantum computing, it's harnessing the strangeness of quantum mechanics to build computers. And these computers can solve problems that today's computers just can't even touch.
Okay, so before we get into Microsoft's big reveal here, can you just give us the why? Why is quantum computing such a big deal? Why should people care about this?
Sure, so imagine you're trying to design a new drug, or you want to create a super efficient battery. These tasks, they all involve understanding how tiny particles interact. And it's that interaction that requires a level of computational power that our normal computers just can't handle. There are too many variables, too many possibilities. A quantum computer could theoretically cut through that complexity. They could help us design new materials. We could develop personalized medicine tailored to somebody's own DNA. We could even revolutionize things like artificial intelligence.
So it's like unlocking this whole new level of problem solving. We're talking about tackling challenges that it just seemed insurmountable until now. It sounds like there's this global race to build these things. We've got Google, IBM, and of course Microsoft. They're all pouring billions into quantum research. But you mentioned that Microsoft is taking a different approach here. What makes their strategy so risky?
Well, companies like Google and IBM have been focusing on building quantum computers with more and more qubits. Now, Microsoft has been kind of quiet. They've been placing their bets on something called topological qubits.
Okay.
And to understand why this is so risky, we need to get into some particles that you might not have heard of before. We're talking about Majorana fermions.
Okay, you're going to have to break this down for me. What is a topological qubit? How do these Majorana fermions fit into all of this? Why is it different from what these other companies are doing?
Okay, think of it this way. Imagine you have a rope and you tie a knot in it.
Okay.
That knot, in a very simple sense, represents a topological qubit. It's defined by its shape, that's its topology, right? Rather than the actual material that the rope is made of.
Interesting.
Now, Majorana fermions, these particles, are what Microsoft believes can create these knots
Huh.
within their quantum computing system. It's a completely different approach than using superconducting transmon qubits like those used by Google or trapped ions that are favored by companies like IonQ.
Okay.
Microsoft's method relies on creating these topological qubits. They're using a special material called a tow-conductor, and they're braiding these Majorana particles inside of it.
So they're not just trying to build a better qubit. They're trying to build a fundamentally different kind of qubit, using particles that a lot of scientists weren't even sure existed.
Exactly. And for a long time, it seemed like Microsoft was really lagging behind, especially when you compare their qubit count to their rivals. But they just unveiled their Majorana 1 chip, and it's definitely making some waves.
Okay, so tell us about this Majorana 1 chip. What's so special about it?
This chip is made with indium arsenide and aluminum, which is interesting because that means it can be controlled using standard computing equipment. But the real kicker is that it only has 8 qubits. That's far fewer than its competitors.
Right.
But Microsoft says because these topological qubits are more stable and less prone to errors, they don't need as many.
Wait, so less is more in this case. That seems kind of counterintuitive.
It is, but you have to remember that one of the biggest challenges in quantum computing is error correction. Qubits are incredibly fragile. They're susceptible to noise from the environment, and that leads to errors in calculations. Microsoft believes that the stability of their topological qubits gives them an advantage in overcoming this hurdle.
So they're saying our qubits are so good we don't need as many. It's a pretty bold claim, but are they just blowing smoke here? I mean, is there any validity to this?
It's definitely a gamble. They're putting a lot of faith in this unproven technology. One of Microsoft's top executives, Jason Zander, he said that they had to invent the ability to go create this thing, atom by atom, layer by layer. So that just shows how complex and difficult this is, what they've achieved.
Yeah, that sounds really, really difficult. I guess that's why Professor Philip Kim from Harvard called it an exciting development, pointing to their use of semiconductors and superconductors as a very promising path. But I'm sure there are some skeptics out there. I mean, not everybody's buying into Microsoft's hype, right?
Oh, yeah, you're right. Not everyone is convinced. Professor Paul Stevenson from Surrey University said that while it is a significant step, it's too soon to be anything more than cautiously optimistic. And that's understandable. I mean, we need to see more evidence, more research before we can truly say whether Microsoft's gamble is going to pay off.
Yeah, it really does feel like we're at this crucial turning point. Microsoft's claim has definitely injected a lot of excitement, a lot of uncertainty into this quantum computing race. But what I find so fascinating is that even if this approach with topological qubits doesn't work out like they hope, all this competition, it's really pushing the boundaries of what's possible.
Yeah, absolutely. It's a classic example of how innovation often comes from competition, right?
Right,
So each of these companies are trying to crack the code. They want to build a truly useful quantum computer.
right.
And that drive, that competition, that's what leads to these discoveries, these incredible advancements along the way. I mean, think about the early days of space exploration. The race to the moon led to all these spin-off
Right.
technologies, and they benefited society in ways nobody could have imagined.
Exactly.
In the same way, the pursuit of quantum computing, it's already driving progress in areas like materials, science, and cryptography, and even algorithm development.
It's like a technological space race. But instead of reaching for the stars, we're delving into this subatomic world. And you're right, the journey itself is so valuable. But let's shift gears a little bit.
Sure.
Let's bring this back to our listener. I mean, we've talked about the potential of quantum computing, but it can be hard to imagine how this will impact our lives.
It's true. Quantum computing is usually portrayed as this abstract thing, something that's far removed from our everyday experiences. But it's not. The applications could touch so many parts of our lives.
Exactly. So for our listener out there, think about something you're passionate about, your field. How might quantum computing change things in that area? Could it revolutionize healthcare? Could it lead to personalized treatments based on your genes? Could it change energy production, make it more efficient, more sustainable? Could it even change the way we communicate, how we interact with the world?
It's mind-boggling when you really think about the possibilities. Let's say you're really into environmental science. Quantum computing could help us develop new materials that can capture carbon from the atmosphere, way more efficiently than anything we have right now. That could help us fight climate change. Or maybe you're into finance.
Right.
Quantum algorithms could revolutionize things like risk assessment and portfolio optimization. That could lead to more stable financial systems.
These are just a couple examples, and I bet our listeners can come up with even more incredible applications within their own areas. I think the main point here is that quantum computing isn't some futuristic concept. This is a technology that has the potential to reshape industries, to impact our lives in ways we can't even imagine right now. And just understanding its potential is the first step towards harnessing that power for good.
Absolutely. It's important to acknowledge the challenges, the uncertainties that are ahead, but it's equally important to embrace that excitement, the potential that quantum computing holds. This is a technology that could change the world as we know it, and we're all part of this journey together.
And it's a time of tremendous anticipation, a little bit of awe at what all this could lead to. And as we wrap up our deep dive into quantum computing and these claims that Microsoft is making, it feels like we're really standing on the edge of something huge, something transformative.
It does, doesn't it? It really does. And Microsoft's gamble, I think it's a powerful reminder that we're in this age of accelerating technological advancement.
Right.
These kinds of breakthroughs that we're seeing today, I mean, they were unimaginable just a couple decades ago.
And this is really just the beginning. We've talked about how quantum computing can change things like medicine, materials, science, artificial intelligence, but honestly, we're probably just scratching the surface here.
Yeah,
It's like trying to imagine the internet back when we were using dial-up modems.
right.
We could kind of see the potential, but the full scope of it was just beyond our grasp.
It's a great analogy. Who could have predicted things like social media or e-commerce? All the ways the internet has changed our lives. I mean, in the same way, the ripple effects of quantum computing are going to be way bigger than we can imagine right now.
So as we kind of step back and look at the big picture, what stands out to you? Like, what's the most important thing from all this, from Microsoft's claim and just the whole quantum computing world in general?
For me, it's the realization that this is a pivotal time. We're moving from a world where computing is limited by classical physics to one where quantum mechanics, those bizarre rules, can actually be used to give us these incredible capabilities.
Right.
And like with any technological revolution, there's going to be bumps in the road.
Absolutely. We got to think about the potential downsides, the ethical stuff, making sure these powerful technologies are used responsibly for everybody's benefit. But along with those warnings, we should also just kind of be in awe of what quantum computing could bring.
Absolutely. It's time for curiosity and for critical thinking to really get involved in these conversations and stay informed as this technology keeps developing.
And that's exactly what we're trying to do here on The Global Take. We break down these complex topics, like quantum computing. We explore all the different sides of it, and hopefully get you interested too. And if you're as fascinated by these big leaps in technology as we are, hit that subscribe button. We'll keep you updated on everything from artificial intelligence to biotech, all the incredible things that are shaping the future.
Thanks for joining us on this deep dive, and until next time, keep those minds curious.